We'll start a new chapter now. It's on triangles. We're going to do a whole lot with triangles. Triangles are the basic building block in our universe. Most stable. Know a whole lot about triangles, and of course you know a whole lot about other structures. For instance, we can make triangles out of rectangles and almost anything we can create triangles out of. So we're going to get into those and learn a whole lot about them. First thing we need to know is how to classify triangles. And triangles can be classified by their sides and by their angles. So we're going to start by classifying by their sides. I think most of you know all this stuff. Something you took a long time ago, but let's review it. Classifications by sides. We have scalene triangles. All the sides are different lengths. Okay, scalene. All the sides are different lengths. Or none of the sides are the same length. For instance, here's an example of one. 3 different lengths to the sides. Isosceles. At least 2 sides are congruent. Now, very important, because I think one of the ways you've learned this is 2 sides are congruent. We're going to add in front of that, at least 2 sides are congruent. So how many sides could be congruent and it still be isosceles? 3. So, talk about that in a minute. At least 2 sides are congruent. Here's an example. We have 2 sides that are congruent, marked by the little lines, plus we have the measurements. Okay? And then we have equilateral. All the sides are congruent. Marked by the little lines, all of them are 6. Now, let's go back to this definition and this definition. Equilateral triangles, the symbol for triangles, are also isosceles. Why? Because isosceles says at least 2 sides are congruent. Well, do equilateral triangles have at least 2 sides that are congruent? Yeah. So they are also isosceles. Okay, now let's look at our classifications by angles. We have 4 classifications by angles. We have an acute triangle. Let's get this set up correctly. We have an equiangular triangle. We have an obtuse triangle. And then we have what's called a right triangle. Well, an acute triangle is just what it says it is. All of the angles are acute. That means they're greater than 0 and less than 90 degrees. All 3 of the angles. And here's an example. 35, 80, and 65. All of them are between 0 and 90 degrees, adding up to 180. Equiangular is exactly what it says. Equal angles. All the angles equal 60 degrees. Equiangular triangles are also acute angles. Why? Because 60 degrees is acute. Okay, and here's an example. All the angles are 60 degrees. Now, equiangular is also going to have to be what else? Talk about it later. Obtuse triangle. One angle is obtuse. That means that angle is greater than 90 and less than 180. Okay? Here's an example. We have a 115 degree angle. That's obtuse. That makes that triangle obtuse and classifies it as obtuse. The other 2 angles are going to be acute. Okay? They have to be. We'll look at that and prove that a little bit later. Okay? So there's an example of that. A right triangle. In a right triangle, one angle is a right angle. It equals 90 degrees. Okay, here's an example of that. We have the symbol down here that indicates that that's a right angle. So therefore that triangle is going to be a right triangle. And the other 2 angles are acute angles. Okay? And they also are complementary. We'll talk about that a little bit later too. These are the 2 different types of classifications for triangles. Now we're going to do a combination and see which could be what. Now what we want to do is we want to look at all these different classifications, different types. Classifications by side are along the top here. Classifications by angles are along the side over here. What we're going to do is construct a truth table to determine what types can exist together. Can a scalene be an acute? Yeah. Scalene can be acute. That's true. Can a scalene be equiangular? Well, think about equiangular. What's true about equiangular? They're also equilateral. Well, if it's equilateral, can it be scalene? This is true always. If that's true, then this has to be false. Why? Because scalene says what? All the sides are different. Well, if equiangular says all the sides are the same, then it certainly cannot be scalene. Okay? Now, can acute be isosceles? Can all the angles of an isosceles triangle be acute? Yes, sure can. Can an acute angle be equilateral? Well, equilateral means it's equiangular, which means at 60 degrees. 60 degrees is acute, so this is definitely going to be true. Okay, can equiangular be isosceles? Well, equiangular says it's equilateral. What's the definition of isosceles? Remember we said isosceles is at least two sides are congruent? At least two sides? How many sides are congruent on an equiangular? 3. So can it be isosceles? By definition it is. Okay? Let's talk about obtuse. Can an obtuse triangle be scalene? Yes, it can. Can an obtuse triangle be isosceles? Yes, it can. That is true. Can an obtuse triangle be equilateral? No, because it has to be equiangular or acute, so this is going to be false. Cannot happen. Okay? Can a scalene triangle be right? Yeah. We can draw a scalene triangle with a right angle in it, can't we? There's nothing to keep that from happening. So that's true. Can a right triangle be isosceles? We can have a right isosceles triangle. Vertex angle can be 90 degrees. No problem with that. Can a right triangle be equilateral? Think about that one. An equilateral triangle is equiangular. By definition, equiangular says all the angles are 60 degrees. A right triangle has to have at least what? Has to have one 90-degree angle. So this one is going to be false. Okay? So those are combinations. Look at them. See if you can prove those out. See if you can draw an example of each one. See which ones maybe I got wrong up here. But look at your classifications, definitions of those classifications, and see if you agree with this. Let me know.